Now, these are the most complicated type of problems that you're going to see in this section. So we're going to work on still solving radical equations. Now, but this time we're going to see multiple radicals, so I'm going to see more than one. Now, when you have that kind of situation, what you want to do is your first step is to isolate one of the radicals. It doesn't matter which one you isolate, but you just want to get one of them by itself. So, for example, in problem number 1 here, I'm going to get the square root of a, this guy right here on the other side. So what I'm going to have is this. I'm going to have the square root of a minus 9 is equal to the square root of a minus 3. Now I'm going to square both sides. You've got to be careful when you do that, because this guy over here on the right side has got to be FOILed. So this guy right here is a minus 9. This guy over here, okay, is going to be the square root of a minus 3 times the square root of a minus 3. Now I'm going to spare you some of the details here of the FOILing. You can do those on your own. So square root of a times square root of a is just a. Then we've got a negative 3 square roots of a, but we got two of those, right? So we're going to have negative 6 square roots of a. And then we're going to have plus 9. So if you don't know how I got this, FOIL this thing out. Okay. Now we still have a radical in here. And so the idea, the steps, are to first isolate one radical and square. Once you've done that, you repeat the process. You isolate any other radicals and square again. So we're going to move this guy and possibly this guy over to the other side. So here's what I've got. I'm going to subtract a from both sides. Well, when I do that, I actually get rid of these two guys, so that's kind of nice. And now I'm going to subtract 9 from both sides, so on the left side I'll have negative 18. On the right side I still have the negative 6 square root of a, and so I'll divide both sides by negative 6, and that'll be 3 is equal to the square root of a. And so if I square both sides again, which is the repeating process here, I get 9 is equal to a. But since I did a whole bunch of squaring here, I should check to see if that's actually a solution. So we go back to the original, which is the square root of a minus 9 minus the square root of a is equal to negative 3. So this gives me 9 minus 9 minus the square root of 9. So this is 0 minus 3, and that gives me negative 3, and it checks. So this is our solution. Let's go ahead and check another one now, or try another one here. So let's clear this out of the way. And let's clear this out of the way too. Okay, with this right here again, we isolate a radical. Well, that's good because we already have one of the radicals by itself. So we're going to go ahead and square both sides. So the left side becomes b plus 4. The right side becomes 2 minus the square root of 3b squared. So we got to FOIL this now. So this would be b plus 4 is equal to 2 minus the square root of 3b times 2 minus the square root of 3b. So this will be 4 minus 4 square roots of 3b plus 3b. Now we'll move everything except for the radical onto the other side. So we can get rid of the 4 on both sides. We can subtract 3b from both sides. So this will give me negative 2b is equal to negative 4 square roots of 3b. We'll divide both sides by negative 4, which will give me b over 2 is equal to the square root of 3b. And if we square both sides, we have b squared over 4 is equal to 3b. Now we got to try to solve that. So let's multiply both sides by 4. So we get b squared is equal to 12b. So b squared minus 12b is equal to 0. Or b times b minus 12 is equal to 0. Zero product property tells us that either b is 0 or b is 12. But again, because we did some squaring in here, we got to check. Well, if I plug in 0 on the left side, so here's our check. If we plug in 0 on the left side, we get the square root of 4, which is 2. If we plug in 0 on the right side, we get 2 minus the square root of 0, which is also 2. So this guy right here is okay. Now let's check 12. So when I plug in 12 here, I get the square root of 16, which is 4. And over here, I get 2 minus the square root. 12 times 3 is 36. So that's 2 minus 6, which is negative 4. And so that does not check. So b equals 0 is my only solution. Okay, let's go ahead and try one or two more here. What if we add something like this? The square root of y plus 2 is equal to the square root of y plus 3, minus 1. Well, again, we have one of the radicals by itself. It's isolated, so we can square both sides. So this side will become y plus 2. This side becomes y plus 3 minus 1 times the square root of y plus 3 minus 1. When we FOIL this, we get y plus 3 minus 2 square roots of y plus 3 plus 1. So you got to FOIL this guy out to get this. So that gives us y plus 2 is equal to y plus 4 minus 2 times the square root of y plus 3. So the y's cancel, and if I move the 4 over, I get negative 2 is equal to negative 2 square roots of y plus 3. Divide both sides by negative 2. I got 1 is equal to square root of y plus 3. Squaring both sides gives us 1 is equal to y plus 3, which means that y would have to be equal to negative 2. So now we'll check. And if you check that, you get the square root of negative 2 plus 2 should be equal to the square root of negative 2 plus 3 minus 1. This side gives me 0. This side gives me square root of 1 minus 1, which is 1 minus 1, or 0. So it checks.